All right, this is a base plus base problem. And the reason that I know that is that potassium hydroxide is on my list of strong bases, and so is calcium hydroxide. And for a base plus base problem, my goal is to get moles of OH from both bases so I can add them together, find my molarity, eventually find my pH. So for the potassium hydroxide, we have 0.008 molar. I'm plugging into molarity equals moles over liters. For the liters, I need to convert it from milliliters to liters, and so it's 0.2. 0.008 times 0.2 gets me my moles of KOH of the whole base to be 0.0016. But because we don't have a 2 with the hydroxide, I know it's a 1-to-1 ratio, and so this is my moles of OH from the potassium hydroxide. Whereas calcium hydroxide is CaOH2. That 2 means I'm going to have to deal with the ratio at some point. But starting the same way, molarity is moles over liters. Again, I converted the milliliters to liters. 0.004 times 0.8. My moles of calcium hydroxide, not just my hydroxide, because I use the molarity of the calcium hydroxide, is 0.0032. To know if you're multiplying or dividing by 2, you'd have to think through the dissociation. What I want is just the OH, like we have over here. And if you look at the dissociation, there's a 2 in front of it. Or you can look at just the OH and know that there are 2 of them. So what we want is the 2 hydroxides that are in the 1 calcium hydroxide. So this is why it's 2-to-1 rather than 1-to-2. Base to OH, we're multiplying by 2. OH to base, we're dividing by 2. If you want to memorize it, not my preference, but it does always work that way. And so that gets us 0.0064. That's a 4, not a 9. It's a 4 moles of OH. Since these are both moles of OH that we have here, 0.00, oops. I did not mean to erase all that. Since these are both moles of OH that we have, what we end up doing is adding them together. 0.0016, let me clear the screen, plus 0.0064, that's going to get me my total moles of OH, which is 0.008. I now want to find my molarity of OH. Since that's what I have the moles of, that's what I have to find the molarity of, by taking those total moles over my total volume. So 800 plus 200 is 1,000 milliliters or 1 liter. So I end up with my OH molarity of 0.008. Taking the negative log of my OH will get me my POH to be 2.1. I want the pH, so I have to subtract from 14. 14 minus 2.1 gets me 11.9. Also, since this was a base plus base problem, we know we have to end up with something basic, pH above 7. So I shouldn't stop at that 2.1 number, like if you weren't sure if that was pH or POH. We know we need an answer above 7 for the pH of a base. That's it.